The star of Tau Ceti is a main sequence G-type star that's very similar to our Sun. Often referred to as a solar twin, Tau Ceti is the nearest Sun-like star to our solar system. Hi everyone, Vega here, and in today's video we take a trip down memory lane with a re-edited and re-recorded version of one of our very first videos. Can we make a trip to Tau Ceti in a day? Let's get to it. The star of Tau Ceti lies just 11.9 light years away and carries the classification of G8 main sequence. This makes the star slightly smaller and indeed slightly dimmer than our Sun. If you ever fancied taking a trip there, it seems quite a long way away, doesn't it? But maybe we might be able to make it in a day. The star only has about 78% of the Sun's mass, and it's the closest solitary G-class star to our system. Importantly, and as we might expect for a G-type main sequence star, Tau does appear to be very stable, with very little stellar variation, although it does slightly differ in that it's metal deficient, or in other words, low in elements other than hydrogen and helium, relative to the Sun. It shines with a dim but visible apparent magnitude of 3.5, and if we turn the camera around, as we see from Tau Ceti, our Sun would be in the northern hemisphere constellation of Boötes, with an apparent magnitude of around 2.6, which would be around the same brightness as the stars of Aldebaran, Akrab or Aludra. Interestingly, observations have detected more than 10 times as much dust surrounding Tau Ceti as is present in the solar system, and indeed since September 2012 there's been evidence of at least 4 planets, all likely super-Earths orbiting the star, with 2 of these potentially in the habitable zone. For the purposes of today's video, however, we're going to be focusing only on the star itself, and don't forget to check out the video on Tau Ceti's planets if you haven't already. I'll link it in the description. In this graphic we see Tau compared to other local stars, the Alpha Centauri system, Barnard's star, the brightest star in our local vicinity of Sirius A, F-class star Procyon, and also the binary K-type stars of 61 Cygni. Of course all these stars are in our local area, and quite curiously we see that Alpha Centauri b, also known as Ptolemy, is actually slightly larger than Tau, but the difference is that Tau Ceti burns slightly hotter, which does push it into the G-class, whereas Ptolemy is not quite hot enough and remains a K-type star, but indeed both stars are on the boundaries. With regard to Tau Ceti's habitable zone, we can see in this graphic that it's slightly smaller than the Sun's and begins at around 0.55 astronomical units, stretching out to around 1.3. In our own system this would probably rule out Mars, as it would be just too cold, but it might give Venus a better opportunity, although of course with Venus it's always difficult to know, given that it has such a thick dense cloud cover. It does remain possible, but even in the Tau Ceti system it may be too hot, should it ever find itself there of course. You can also see the Tau Ceti planets here, and although I've said I won't discuss them on this video, you can clearly see there are 2 potential worlds that do look very interesting indeed, and on the extremes of the inner and outer edge of the Tau Ceti habitable zone. So the question we're here for is, can we make it to Tau Ceti in one day? You might say to yourself, no, that's physically impossible Vega, it's ridiculous, it's 11.9 light years away. And indeed the figure in light years almost makes it seem short itself, but we must remember that that translates to some 112.6 trillion kilometers, which is of course a 15-digit number. Well, the answer to the question, and if you'll excuse the slightly jittery audio from an older video, I'm now passing myself over to my younger self to explain exactly how we might do it. So how long would it take us to get there? Let's imagine we could fly a Boeing to Tau Ceti, which probably isn't possible. Well, let's just imagine we could do that. Cruising speed of around 600 kilometers an hour, which translates to 0.17 kilometers a second. And here we are, that would take us around 21 million Earth years to get there. And obviously as a percentage of the speed of light, the Boeing is practically 0 light speed. And as you can imagine, that also means there's virtually no time dilation as well, so we don't gain anything there either. Voyager 1 of course is one of the fastest bodies we've ever created, and a cruising speed of 61,000 kilometers an hour. So what that means is we're actually going at 17 kilometers a second, and if Voyager was going to Tau Ceti, which of course it isn't, but if it was, it would take 209,000 years. So yeah, pretty quick isn't it, compared to 21 million years, and we've moved up a few of the decimal places. So Voyager's travelling at 0.005% the speed of light, and still no relative time dilation with this one. Some of our older members might remember Starfleet, one of my favourite series as a child, and this is the X bomber, and let's increase the speed somewhat because I think we're at a bit of a snail's pace so far. Let's start at 50 million kilometers an hour, or 13,800 kilometers a second. Now X bomber would reach Tau Ceti in 257 Earth years, so we get a bit quicker, but still not enough to get there within a lifetime. But we are getting to percentages of the speed of light, 4.62%, and that's a relative speed now. And interestingly, if you're on X bomber, it would take only 256 years, or some 257 to those of us on the Earth. So we're all starting to see some relative time dilation effects here. Next, a made-up ship, the castor, and let's multiply by 10, so we're now going at 500 million kilometers an hour, which is not beyond the realms of possibility for us. Perhaps we could use an antimatter drive. Now the castor travels at 138,000 kilometers a second, and we're talking about 25 Earth years now to reach Tau, so still a long time, but getting to be reasonably well reachable, and certainly within a lifetime, at 46% the speed of light. And the relative time dilation for those of you on the ship would only experience 22.7 years now, so we have saved a few years in travel time for those on the Earth. Alien isolation fans will know the torrens, and I don't know what speed it goes, so feel free to argue with me in the comments if you know, but I've imagined it going 800 million kilometers a second now, which is interestingly and makes 222,000 kilometers a second, and it would now take just 16 Earth years at 74% the speed of light. It's also very interesting now that we're starting to see relative time dilation, so those of you on board the torrens with Amanda would only get to experience 10 years, so there and back 20-year round trip, and it's certainly starting to be feasible. The alien fans will know the Nostromo, and again I've got no idea what actual speed it's supposed to have got in the movie, but let's imagine it goes 1,070,000,000 kilometers an hour, which is almost 300,000 kilometers a second, and now it takes 12 Earth years to get to Tau Ceti, and we're almost at the speed of light, at 99% of it. You can see the time dilation is also really kicking in, so 12 years on those of Earth for those of you who are watching, but just 1.6 years on board the Nostromo, so it's easily capable of doing it in a 3-year return trip for those on board. Finally, the Sulaco, the latest ship in the Aliens franchise, and let's imagine the Sulaco goes almost at the speed of light. So there we are, 1,079,000,000, almost 80 million, kilometers an hour, and almost 300,000 kilometers a second. And that's going to take us 11.905 Earth years. But here we are, just 0.02 years for those on board, and that's actually almost a day, or slightly over. So we could actually do a day trip to Tau Ceti if we wanted, at least those travelling on board, if we could get up to almost the speed of light. Tau Ceti is a solitary G-type star that lies in our immediate vicinity. The star itself is slightly smaller than our Sun and contains less heavy elements. Despite that, it is thought to have at least 2 potentially habitable planets. Almost the same size and luminosity as Alpha Centauri b, it does burn slightly hotter, which pushes it into the G-class. If we could create a ship that went 99.999972% of the speed of light, it would be possible to reach the star in a day, at least for those travelling on board the starship. The rest of us back on Earth, however, would have to wait 11.9 years for the ship to arrive, and then another 11.9 years for its crew to be able to send us back a signal. Thanks for watching, and consider subscribing if you haven't already. If you would like to support the channel further, you could consider joining the channel, or alternatively buy me a coffee, and I'll link this in the description. Thanks to those of you who have already done so. Take really good care of yourselves, look after your friends and family well, and I'll see you on the next one.